Hello students, today we can solve question from the chapter quadratic equation, which is a subtopic of your complex numbers plus one topic, plus one chapter. Okay, now let us solve the first question. 2022, no questions were asked. 2021, one question was asked. Okay, a quadratic equation is given, z squared minus 4z plus k equal to 0. K is a real number. One root is given. Alpha is equal to 2 minus 3i. You know that in a quadratic equation, if the coefficients are real, then the complex roots will be conjugate pairs. So if alpha equal to 2 minus 3i is one root, then the other root beta is equal to conjugate of 2 minus 3i is 2 plus 3i. Now, sum of the roots is very easy. Alpha plus beta equal to 2 plus 2, which is equal to 4. Alpha beta equal to, you multiply 2 minus 3i and 2 plus 3i. So you are getting 4 plus 9, which is equal to 13. Okay. You are being asked to find out alpha squared plus beta squared. Alpha squared plus beta squared is alpha plus beta the whole square minus 2 alpha beta. So it is 16 minus 2 into 13, which is equal to minus 10. So that is appearing in option E. Okay. Now we go to the next 2020 question from quadratic equation. Only one question was asked in that year. It is a similar question only. X squared minus 4x plus c equal to 0. C is real, same concept. The coefficients are real. So the roots, complex roots are conjugate pairs. 2 plus I is one root. Then other root will be conjugate of 2 plus I, which is 2 minus I. You are being asked to find out the value of C, that is product of roots. Alpha into beta is equal to C, which implies 2 plus I into 2 minus I equal to C. 4 plus 1 is equal to C. C is equal to 5. So that is appearing in option B. Okay. Now, in 2019, 6 questions were asked. Now, the first question. A and B are positive integers. That means they are natural numbers. A squared minus B squared is prime. A squared minus B squared is A plus B into A minus B is prime. Which implies property of prime number. A plus B into A minus B is divisible by itself or by 1, because a prime number is divisible by itself or by 1 property. A plus B not equal to 1, because since A comma B belong to natural numbers, therefore A minus B is equal to 1. Now, in that case, A squared minus B squared is equal to, it is A plus B into A minus B. A minus B is equal to 1. So A plus B into 1. So which is nothing but A plus B. So answer for that question is option B. Okay. You are being given a second degree equation. I'm not telling that it is a quadratic equation. Why? Because a quadratic equation will be having only 2 roots. But here, this equation has got more than 2 roots. Now, if a second degree equation has got more than 2 roots, then it is called an identity. So result. What is an identity? Identity is an equation which is true for all values of x. Okay. If this second degree equation is an identity, therefore, coefficient of x squared must be equal to 0, coefficient of x must be equal to 0, and constant term also must be equal to 0. So remember, if a second degree equation is an identity, then coefficient of x squared is equal to 0, equation 1. Coefficient of x, a squared minus 5a plus 6 is equal to 0. And finally, a squared minus 4 is equal to 0. Now, from the first equation, we solve it. So it is a minus 1 into a minus 2 equal to 0, which implies a equal to 1 or 2. Second one, a minus 3 into a minus 2 equal to 0. So which implies a equal to 3 or 2. Third one, a plus b into a minus b is equal to 0, which implies a is equal to, it is a plus 2 into a minus 2. In the place of b, here it is 2. A plus 2 into a minus 2 is equal to 0. So a equal to minus 2 or 2. Now, all the equations are being satisfied by a is equal to 2. So when a is equal to 2, the given equation is an identity. So answer for that question is option C. Now, x is equal to 3 raised to 100. So you want to find out the digit appearing in the unit place when you are writing this as a natural number. Okay, so I am rewriting the same expression as 3 raised to 4, 4 raised to 25, which is equal to 81 raised to 25. Now, when 1 is appearing in the base, however times we multiply, the digit in the unit place will be 1 only. When you multiply 81 as many times as you want, the digit appearing in the unit place will be always equal to 1. Okay? Therefore, digit appearing in the units place is equal to 1. Okay. So that is appearing as option B. Okay. Now the fourth question. 7 minus 4, 4 raised to x squared minus 4x plus 3 plus 7 plus 4, 4 raised to, it's not 4, it's 4 root 3, sorry. it is 4 root 3. So I am writing here 4 root. Here also 4 root 3. Okay. X squared minus 4x plus 3 is equal to 40. Now, there is a peculiarity of these two numbers, which are the 7 minus 4 root 3 and 7 plus 4 root 3. When you multiply these two numbers, we are getting 1. That means one number is a reciprocal of the other. Okay. One number is reciprocal of the other. Now, you know that 7 minus 4 root 3 and 7 plus 4 root 3. When you add, you are getting what? 40. So here the power is 1. So one case is the power x squared minus 4x plus 3 is equal to 1. So x squared minus 4x plus 2 equal to 0. So x is equal to 4 minus b plus or minus root of b squared minus 4ac. 16. It is 3, no? Yeah. So 16 minus 8 divided by 2. So when you simplify, you will be getting 16 minus 8 is 8, 2 root 2. So you'll be getting 2 plus or minus root. So from this stage itself, you will be able to understand that option E is correct. But let us complete the solution. Now, how 2 also is becoming solution? Because 7 minus 4 root 3 raised to minus 1 plus 7 plus 4 root 3 raised to minus 1 also is 40. Why? Because since 7 minus 4 root 3 raised to minus 1 is 7 plus 4 root 3. One is reciprocal of the other. And 7 plus 4 root 3 raised to minus 1 is 7 minus 4 root 3. So there are two possibilities. So therefore, x squared minus 4x plus 3, if it is equal to minus 1, then also this equation is being satisfied. So find out the value from x from here. So now it is very easy. It is x squared minus 4x plus 4 is equal to 0, which is x minus 2 the whole squared is equal to 0, which implies x is equal to 2. So x is equal to 2. X is equal to 2 plus or minus root 2, option E. So when you are getting 2 plus or minus 2, root 2, at that time itself, you will be able to write or get the correct answer in Keam. Okay. Next question, the value of root of 7 plus root of 7 minus root of 7 plus root of 7 minus, etc. So let us assume that the given expression is x. What is it? Square root of first 7 plus, then square root of 7 minus, then square root of 7 plus, then square root of 7 minus, etc. up to infinity. We square it. Therefore, x squared is equal to what? 7 plus square root of 7 minus square root of 7 plus square root of 7 minus etc. up to infinity. Now we take 7 from RHS to LHS. X squared minus 7 is equal to root of 7 minus root of 7 plus root of 7 minus etc. up to infinity. Again you square it. X squared minus 7 the whole square is equal to 7 minus square root of 7 plus square root of 7 minus etc. up to infinity. Now let the first equation be equation 1. So this expression is x from equation, okay, which implies x squared minus 7 the whole square is equal to 7 minus x from equation 1. Now solving this is little tedious, so let us verify. X is equal to 3. Satisfy above. Hence, x is equal to 3 means the value of this expression is equal to, because you are getting a 4th degree polynomial equation, so solving is difficult. So we verify 4 different values which is given in the option. So we are getting x is equal to 3, which is appearing as option C. Now we are going to the 6th question. 3 to the power log x to the base a plus 3 into x to the power log 3 to the base a is equal to 2. Now result. This result we are using. X to the power log y to the base a is same as, we can interchange x and y. Y to the power log x to the base, which all you can interchange x and y. So I will mark here. This x, this is y, this x. If you interchange it, here y will come, here in the place of x, y will come, in the place of y, x will come. Okay, we are using that property. Now equation 1 is 3 raised to log x to the base a plus 3 into x to the power log 3 to the base a. X and 3 we are interchanging, so we are getting 3 to the power log x to the base a is equal to. So we can add it then in that case. So we are getting 4 into 3 to the power log x to the base a is equal to 2. So we are simplifying it. So which is equal to 3 to the power log x to the base a is equal to 1 by 2 or 2 raised to minus 1. Now we are taking log to the base 3. Okay. Therefore, log to the base 3 of 3 to the power log x to the base a is equal to log to the base 3 of 2 raised to minus 1. So by using property of logarithm I am simplifying. This is equal to log x to the base a into log 3 to the base is equal to minus log 2 to the base. Okay, which property? Log 8 to the power b is equal to b log. So log 3 to the base 3 is 1. Log 3 to the base 3 is equal to log of any number to the base itself. Number must be positive and not equal to 1. So ultimately, what are you getting? Log x to the base a is equal to minus log 2 to the base 3. And again, by using property, x is equal to a to the power minus log 2 to the base 3. Okay, your property of logarithm we are using in each stage for simplification. So answer for that question is option D. So here we haven't completed actually. Again, we are using the given, you can interchange a and 2. It's not completed like. Here x and y we can interchange. Same again we are using the same property which all we are interchanging a and 2. This is equal to 2 into minus log a to the base 3. Because the answer is given in that. Okay. 2 to the power minus log a to the base 3. Actually, it is a to the base 3. There is a correction over here. Option D. Okay. That correction you should know. Okay. Now we are going to the next, 2018 question. 4 questions were asked from this chapter. If the equation s squared plus ax plus 1 is equal to 0 and s squared minus x minus a is equal to 0 have a real common b. B is common root. Hence, put x is equal to b in both equations, because a root of a quadratic equation will satisfy that equation. Therefore, b squared plus ab plus 1 is equal to 0. First equation. Second one, b squared minus b minus a is equal to 0. That is equation. We subtract. B squared is getting cancelled. So you will be getting ab minus minus b. So b you can take common, b into a plus b. Then here is again 1 plus, sorry, not a plus b, it is a plus 1, sorry. B into a plus 1. Okay. Then plus 1 plus a equal to 0. Find out b equal to minus of 1 plus a divided by a plus 1. So a plus 1 and 1 plus a both are same, which is equal to minus 1. A simple question. Okay. Now question number 2. X raised to 2 by 5 plus 3 into x raised to 1 by 5 minus 4 equal to 0. So you can reduce it to a quadratic equation if you give a suitable substitution. Put x raised to 1 by 5 is equal to 1. Therefore, the given equation is now y squared plus 3y minus 4 equal to 0. I think you can factorize it, which implies y multiply, you are getting 3 and you are getting -4. So minus 1 and minus 3, is it not? Y minus 1, y minus y plus 4 into y minus. Yeah, that is y plus 4 into y minus, which implies y equal to -4 or y equal to. So first case, y equal to -4. Okay. Therefore, what is y here? X raised to 1 by 5 is equal to -1. So x is equal to -4 raised to 5. So power is odd, so minus is remaining, 4 raised to 5. 4 raised to 5 is nothing but 2 raised to 10. 2 raised to 10, we always remember 1, 0, 2. Now, y is equal to 1. Second case. When y is equal to 1, x raised to 1 by 5 is equal to 1, which implies x is equal to 1. So x is equal to 1 or x is equal to -1024. So answer for that question is option D. Okay. Now this is second question. Answer third question. Okay. F of x is a quadratic expression. Px square plus qx plus r. P, Q, R are constants. P not equal to 0. Now f of 5 equal to -3 into f of. So f of 5, put x is equal to 5. We are getting 5 squared 25p, okay, plus 5q plus r equal to -3 into f of 2 means 4p plus 2q plus r. So when you simplify it, you will be getting 37p, then plus 11q plus 4r equal to 0. Equation 1. Also, f of -4 equal to 0. Put x is equal to -4. So we are getting 4 squared is 16p minus 4q plus r is equal to 0. That is equation 2. You solve these two equations. Okay. You eliminate r. How to eliminate r? Equation 2, you multiply by 4. So you'll be getting 64p minus 16q plus 4r is equal to 0. Now equation 1, 37p plus 11q plus 4r equal to 0. You subtract, you will be getting 27p minus 27q equal to 0, which implies p equal to. Now, therefore, f of x is equal to the first equation. You put p is equal to p x squared plus px plus r equal to 0. Sorry, r. Now it is given that f of -4 is equal to 0. So what information you are getting? F of -4 equal to 0 implies px squared plus px plus r equal to 0 has one root equal to minus. Okay. When you put x is equal to minus 4, it is becoming 0. That means x is equal to minus 4 is one of the roots. Let alpha be the other. Let alpha be the other. So sum of. Therefore, sum of roots is equal to alpha plus minus 4 is equal to, what is the formula? Minus coefficient of x divided by coefficient of x squared. Both are p, which is equal to minus. So you are getting alpha equal to 3 minus 4. When it goes to RHS, it will be plus 4 minus 1, which is equal to 3. Therefore, you need not have to find out the value of R. Without that, you will be able to find out the other root. So the other root is 3. I think you are able to understand. Once you are getting P and Q are equal, directly we are using the result. Sum of roots of a quadratic equation is minus coefficient of x divided by coefficient of x squared. Now, fourth question. You are being given alpha squared is equal to 5 alpha minus 3. Okay, which implies alpha squared minus 5 alpha minus 3 is equal to 0. That's equation 1. Beta squared equal to 5 beta minus 3, which implies beta squared minus 5 beta plus 3 equal to 0. So first equation, it is plus 3. I am correcting. Now, when you observe these two equations, we will be able to conclude that alpha comma beta are roots of x squared minus 5x plus 3 equal to 0. Why? When you put x is equal to alpha, by equation 1, it is being satisfied. When you put x is equal to beta, by equation 2, it is being satisfied. Okay. Now, we know that sum of roots. Alpha plus beta is equal to 5, comma, alpha into beta equal to 3. You have to find out quadratic equation whose roots are alpha by beta and beta by alpha. Okay. Now, what is alpha by beta plus beta by alpha? Sum of roots. Equal to, numerator we have got alpha square plus beta square. Denominator is alpha beta. Numerator it is alpha square plus beta squared is alpha plus beta the whole square minus 2 alpha beta, because we have got only the values of alpha plus beta and alpha beta. You substitute for alpha plus beta. Alpha plus beta squared is 25 minus 6 divided by 3. So on simplification, we will be getting 19 by 3. This is sum of roots. Now product of roots alpha by beta into beta by alpha equal to 1. So it is getting cancelled. Therefore, required equation. Required equation. What is the formula? X squared minus sum of roots, that is 19 by 3 into x plus product of roots 1 equal to 0. Result. Which implies when you simplify, multiply by 3, you are getting 3x squared minus 19x plus 3 equal to 0. That is the required quadratic equation whose roots are alpha by beta and beta by alpha. It is appearing in option E, is it not? 3x squared minus 19x plus 3 is equal to 0. Okay, these are last 5 years questions from the chapter quadratic equation, okay, which was asked in Keam examination. Thank you.